It's the 21st century, and today's world is fast. Technology plays an important part in everyone's day-to-day life. Gadgets are everywhere. iPods, cell phones, digital cameras, laptops, and there are fancier ones, gaming consoles, GPS devices, data cards. The list is endless. But you know something? All these gadgets have one thing in common. They have a mechanism that transforms the input into a unique output. Wondering how it's done? Something similar to this is done by functions. It transforms the input into a unique output, which is exactly what we will explore today. I don't know about you, but this is one gadget I can't do without. Welcome to Math 11. Hi, I'm Shankar. Let me tell you, mathematics involves nothing but logical reasoning where one step leads to another. And our first step is to look at the breakdown of today's episode. We start by defining a function followed by its pictorial representation. We then come to the domain, codomain, and range for a function. Finally, we look at real-valued functions. Hey, let's not forget, marks are a priority, so automatically the exam decoded segment is also a priority. Before getting into pure math, let's brush up a little bit on history. Mathematics started to flourish with the advent of a variable. And how did the concept of a variable help? Well, it allowed us to analyze any situation in terms of a small set of variables. You remember your algebra, right? It also allows us to focus on the relationship between one or more of these variables. Here are a couple of examples. The area A of a circle depends on its radius r via the equation A is equal to pi r squared. So we say that A is dependent on r. Or how about this real life example? The level of the Sensex is based on the prices of 30 prominent stocks. These examples also include a rule which you get from the left column to the right column. The left column contains the variables that are to be combined to yield a corresponding value in the right column. And this rule is what we call a function. Remember, a relation R between the sets A and B is any subset of the Cartesian product A cross B. A function is a relation but with a special restriction. We say that a relation f from a set A to a set B is said to be a function if every element of A has a single image in B. Let's explore this further. Consider two non-empty sets A and B. Now, an element A of the set A can be related to an element B in the set B if we can define a function which can associate A to B. If an ordered pair A comma B belongs to the relation F, then we write F of A is equal to B. The element B is called the image of A under F. The element A is called the pre-image of B under F. And the set of all the images is termed the range of F. This will be a subset of the set B, which is called the codomain of F. That should give you a clear idea of a function. There are 5 different methods to represent a function. The first and the most straightforward one is called the tabular format. Here a function is represented by a pair of columns from left to right, as in a table, where no element is repeated in the first column. The second method is via an arrow diagram. Here a function is shown as a mapping from a set A to set B such that no element in A is left out by the map, and more importantly, no element of A has 2 images in B. Now here are a couple of cases which do not represent functions. Can you tell me why? In the third method, we can represent a function as a set of ordered pairs which are plotted in a plane. The function is a rule of correspondence from elements on the horizontal axis to those on the vertical axis. Notice each value on the x-axis is associated with exactly one value on the y-axis. The fourth method to interpret a function is as a curve on a plane. This is when you're dealing with functions that are defined on an interval of real numbers or all of R. The function represents a curve which a vertical line can intersect only once. So here, cases 1 and 2 do not represent functions in the traditional single-valued sense. The fifth and final method is the algebraic rule, or in the form of sets. For example, a function can be expressed as f from a to b such that f of x is equal to x squared for all x in a. Now a function is also a set in the sense of a relation. So it can be expressed as a set of ordered pairs in which the first element always appears once and only once. I can see you people are all charged up. You may have lots to ask, but I can answer only one of you. So let's hear out our caller's question, shall we?
Hello sir, my name is Chanpreet. I really enjoy your show. In today's topic, I was wondering if there's a way to find out whether a relation is a function or not algebraically.
Now that's a terrific question, Chanpreet. It shows that you were attentive when I was explaining, which is half of your battle won. I'm going to take a short break, but I want all of you to get back to the algebraic rule and see if you can find the answer to Chanpreet's question. Stay tuned, because also coming up after the break, I'll go over the relationship between gadgets and functions. See you soon. It's brand new and I'm still trying to understand its functions. Hi everyone, you're back on Math 11 with me Shankar, and we are in the process of thinking logically to score magically. Before the break, Chanpreet asked us a very valid question. Can we find out whether a relation is a function algebraically? The answer is yes. And to that, I know your next question will be, how is that? Well, consider a relation R defined on the set of integers by a rule. An ordered pair AB belongs to R if B is equal to A minus 2. Here you will find that every element which is an integer will have one and only one image B. So by the definition, the relation R is a function after all. And in this case, the domain and the range of R are both Z, the set of integers. So, now that we've answered Chanpreet's question, let's move on to our next topic. A function which has either all the real numbers or one of its subsets as its range is commonly known as a real valued function. If apart from the range, the domain is also either the set of all reals or one of its subsets, a function will then be called a real function. That was real valued and real functions for you. And before we go further, let's find out the domain and range of a function given an algebraic rule. The domain of a function is the collection of values for which the function is defined. And the range of a function is the set of values assumed by that function. Now I promised to tell you the connection between functions and gadgets, right? So that's what I'm going to do. Think of a function as a rule which assigns a single output to every input. To put it in one crisp sentence, a function is a processing machine which transforms an input into an output. Now it's valid to have a function for which two inputs produces same output, but it is invalid if a single input produces two or more outputs. Get the difference? With all the theory in place, I'm sure that you must be itching to solve a few questions. So, what are you waiting for? Get your pen and paper ready, and here we go. The function f of x given by f of x is equal to 1 by x squared minus 1 is defined on the real number set. Yes or no? Sorry, no shortcuts here. We need to solve this one to figure out. You know how to smell trouble when we have a fractional expression, right? The denominator can never be 0. Well, x squared minus 1 does in fact take 0 values at plus or minus 1, of course. So, f cannot be defined on the full set R as it does not yield any real values at the points plus 1 and minus 1. At all other points, 1 by x squared minus 1 gives us back real values. So the given function f is not defined on the entire real line. However, if we remove the two problem creators, plus 1 and negative 1, then the function will actually yield real values. In general, if we have functions of the type px over qx, the domain will not contain those values where qx vanishes. Such expressions are called rational functions. Let's tackle another one. Consider a function g where g of x is equal to the square root of x squared minus 16. Now find out the domain and range of this function g. Here's a point of confusion. We are told that the square root of any quantity is plus or minus something, right? However, if we refer to this square root as a function, then we must consider only the positive square root, unless otherwise stated in the problem. That's the convention. Now we know that the square root of x squared minus 16 will be a real valued function only when x squared minus 16 is non-negative. So x should be such that the modulus of x is greater than or equal to 4. Therefore, the domain is equal to a set of all real numbers whose modulus is greater than or equal to 4. And the range will be, you guessed it, all non-negative real numbers. We've seen a fair share of functions by now, but what is their origin? Have you ever thought of that? Let's check it out. History of functions is very interesting. Functions appeared for the first time in the manuscript Methodus Tangentium Inversa So de Functionibus, written by Gottfried Leibniz. Leibniz used functions to describe a quantity that was related to a curve. After all, he was busy inventing calculus. In 1710, he published Theodicee, a philosophical work intended to tackle the problem of evil in a world created by a good God. Leibniz claimed that the universe had to be imperfect, otherwise it would not be distinct from God. He then went on to claim that the universe is already the best it can possibly be without being perfect. The famous mathematician Euler invented a symbolic way to say y is a function of x by writing y is equal to f of x. This is a notation that we still use 300 years after its conception. Well, I sure hope your universe is close to perfect after watching Math 11. Make good use of it. It's time for me to take a short break, but before that, let me ask you a question. What is the relation between you and me? Is it a function? I'll be back with the answer, and yes, I know you're waiting for the exam decoded segment. Alright? It's coming up. Don't move. Oh, you're back. I was just talking to a student of mine. Long distance problem solving would have been impossible earlier. Welcome back to Math 11, where math is nothing but a game of numbers. I'm Shankar, your guide to great vistas in the world of mathematics, together with perfect scores. Now, you all heard my question before the break. Remember it? What is the relation between you and me? I bet you're thinking, what an irrelevant question. But if you bothered to find the answer, it would make a lot more sense. If all of you watching me are considered as one set, then you are connected with me through this show. What is the case of many to one relation? And yes, of course, it is a function. But if I were to reverse it, that is the relation between me and you, then you will find that it's just a relation but not a function. Make sense now? Great. And with that, let's do a quick recap of the topics that we've covered today. A function f from a non-empty set A to a non-empty set B is a mapping from A to B such that each element of A has a single image in B. If f is a function from A to B, then A is the domain of f and B is the codomain. The set of all images under f is known as the range of f. A real function is a function with domain as well as codomain as the set of real numbers. I want you to get those marks. So revise, practice, and it's time now for the exam decoded segment, which will show you how to master this topic. As always, we begin this segment with the rapid fire round. It's a test of your concepts and speed. 5 questions, 5 marks. So get ready. Here's my first question. What is the domain of the function f of x is equal to 1 over x? A, r, b, r minus 0, c, c, d, r. Well, the answer is B. Here's your second question. What is the range of the function f is equal to 1, x, 2, y, 3, z, 4, z? Your options are A, b, c, d, B, x, y, z, C, ax, bx, cy, dz, and D, ad. That's correct. The answer is B. Here's question 3. F is a function from the natural number set to itself such that f of x is equal to 2x plus 3. This is for all x in the domain. Then f of minus 3 is A, minus 3, B, 3, C, 9, D, not defined. Very good. The answer is D. Here's question 4. The range of a function is equal to the codomain. True or false? It is false. Great. Finally, every relation is a function, but the converse is not true. True or false? Yes, you got it. It is false. And that's the end of the rapid fire round. 5 marks, you're a high flyer. 3 or 4, you're an achiever. And if you got less than 3, consider yourself a learner. And the next time you guys are net surfing, log on to www.topperlearning.com for online tests and more. This topic is a part of the unit Sets and Functions, which is worth 29 marks in your exam. 4-mark questions are expected from this topic. This chapter will test your conceptual understanding and application skills. Let's now look at how to write an ideal answer based on the conceptual ability. Here's a 4-mark question. Find the domain of the functions 1. F of x is equal to x squared plus 2x plus 1 divided by x squared minus 8x plus 12. 2. F of x is equal to 1 over the square root of x squared minus 5x plus 6. We have function x is equal to x squared plus 2x plus 1 divided by x squared minus 8x plus 12. For the function f of x to be defined, the denominator x squared minus 8x plus 12 should not be 0. You get 1 mark for this. That means x squared minus 8x plus 12 which is equal to x minus 6 times x minus 2 is not equal to 0. Now this expression is 0 either at 6 or 2. So f of x is defined for all real numbers except 6 and 2. So the domain of f is r minus 6, 2. You get one more mark for this. In the second part of the question we have f of x is equal to 1 over the square root of x squared minus 5x plus 6. For f of x to be defined, x squared minus 5x plus 6 should be greater than 0. You get one mark for this, which means x minus 3 times x minus 2 greater than 0, which means x less than 2 or x greater than 3. Therefore, the domain of f as a set is equal to the open interval minus infinity to union 3 infinity. You get one mark for this. So that's the way to score in such a question. I think I've already told you a lot, so I would like to invite a special guest to pump you with some fantastic tips and suggestions. Listen carefully.
Hello students, I'm Taruni. In class 10, you solved most of the questions by using some or the other formula. But determining the domain and range of a function does not involve the use of any particular formula, but the use of the concept. As you are aware, the reciprocal function is not defined at a point which makes the denominator 0. Also remember, the functions of the type root of x minus 4 are not defined if the expression under the root sign is negative. If you keep these 2 points in mind, you are sure to do very well. All the best to you, students.
Well, that's all I have for today. But as always, I'm going to leave you with a quote, and this is one of my favorite personal ones. Charles Colton once said, "The study of mathematics, like the Nile, begins in minuteness but ends in magnificence." To become magnificent at mathematics, you need a little bit of inspiration and a lot of hard work. I'll see you next time with a new topic. Till then, try mastering this one. Goodbye and cheers.